Hi, let us try another example, doing curtailments of the reinforcement in simply supported beam based on the simplified curtailment rules as demonstrated in the diagram here. This represents another common scenario, slightly different from those being discussed in our previous videos. Now in this case, we are talking about the beam dimensions of 150 times 500 over an effective length of 4.5 meter. The reinforcement provided, it would be 2 units of H12mm rebar. Like always, we will start with determining the minimum spacing in order to ensure good compactions of concrete as well as good bond with reinforcement. The minimum spacing is governed by 3 factors here. Bar diameter, which is 12 mm, based on this case. Maximum aggregate size plus 5 mm. Typical concrete will have a maximum aggregate size of 20 mm and a nominal of 20 mm. The biggest value of the 3 shall govern the minimum spacing. Therefore, the minimum spacing, it will be 25 mm. Since we have 2 units of H12 rebar over the beam width of 150, considering the concrete cover 35 and the shielding size of 8 mm, the spacing between the reinforcement bar, it will be calculated as the width 150 minus 2 times the concrete cover of 35 mm minus 2 times the size of the shielding, which is 8 mm, minus 2 units of H12 rebar. This gives you an actual spacing of 40 mm between the reinforcement, which is greater than the minimum spacing. And this will be the arrangements of the reinforcement bar at the midspan. Now, if you refer to the curtailment rules, you can actually reduce the amount of reinforcement bar by half near to the support. However, there will be other requirements govern the final layout of the reinforcement. You need at least 2 units of reinforcement as the bottom bars, 1 at each corner of the link in order to tie the shear link. And the size of the reinforcement will have to be at least 12 mm. Since at the midspan there is already the nominal amount of reinforcement, that means 2 units of 12 mm reinforcement, you cannot do further curtailment. Instead, you will have to extend these 2 units of H12 rebar into the support without any curtailment. Now, you might want to ask, what if the required amount of reinforcement bar at the midspan increases? Let's say 2 units of H20 rebar. Since you only have 2 units of rebar, the same requirement applies where you're going to extend that 2 units of reinforcement into the support. That means your final arrangements of the reinforcement, it will be 2 units at the midspan and 2 units at the support without any curtailment. How about you reduce the amount of reinforcement bar by reducing the size of the steel bar and then doing lapping somewhere here. For example, you have 2 H20 at the midspan with the intention to save the amount of material. You put 2 H16 at the support with the area greater than 50% of the midspan. Conceptually, it is okay, but practically it is not reasonable. In the first place, you do curtailment is to reduce the amount of reinforcement bar required in the member. Now, if you change the size between the midspan and the support. You will need lapping length between the two bars for the transmissions of the stress from one bar to another, and this lapping length can easily go more than 32 times the bar diameter, assuming the lapping regions with good bond conditions. At the end of the day, you will use more reinforcement bar. This is one. Second, it makes the construction process more tedious. You have to cut more bar, do the lapping, do measurements, and there are regions of the lapping you have double running reinforcement bar along the cross section, which may also compromise the minimum spacing between the reinforcement. Therefore, it is not necessary for you to change the size of the reinforcement bar just for the sake of reducing the amount of reinforcement, especially when there is only 2 units of reinforcement bar at the midspan. Therefore, the final solutions for this example: your beam size of 150 times 500 with an effective length of 4.5 meter. The midspan reinforcement, it will be 2H12. Then it is not necessary for you to do any curtailment. You're going to extend the same amount of reinforcement into the support, leading to you the midspan and the support having the same amount of reinforcement.